All right. Welcome, everyone. This is Bring Your Own IP Address to the Cloud. I'm Matt Lewis, a Principal SA with AWS, and we've got Anupam Pandey, a Senior Product Manager with AWS. Let's get started. So first, we'd like to talk about VPC foundations. And when you're building an application on AWS, the VPC is really where you build things like EC2 instances, subnets, route tables, etc. And the VPC is really considered the foundation of the application when you're building in AWS. So in this case, we've chosen an AWS region, and we'd like to use things like Amazon EC2. We'll use VPC, and we create a VPC and allocate a site or address range. In this case, we've chosen a 10.1/16. Once we've got the site or address range, we can then create subnets out of that site or address range. In this case, we've created 2 subnets in 2 availability zones, and we've spun up some EC2 instances. Those EC2 instances, as you can see, have addresses from the site or address range of the VPC. You can also choose whether you want the subnets to be public or private, and this is determined by the route table of the subnets. We might also want to connect to the internet. Or there are some services that sit outside of the VPC, such as Amazon S3, DynamoDB, IoT, etc. And to connect to those, we want to use what's called an internet gateway. So the internet gateway is, think of it like a logical component that attaches to the VPC and allows you to connect to public services and the public internet. Now to do that, we'd use the route table of the subnet that we've created inside the VPC. And you'll see here we've got a route table. It's got the local route of the CEDAR address range of the VPC via local, which is the local router within the VPC. And then we have a default route. The default route is pointing to the IGW. So what that's going to mean is instance A, in this case, has a route out to the internet and out to AWS public services. Now from there, as a 10.1/16 address range is actually a private address range, we'd like to have a public address range that's representative of that instance. And this is what we call an elastic IP. So in this case, we've got an elastic IP, 54.1.13.43, which is representative of instance A's private address. Now, if you did do something like an ifconfig on the instance itself, you wouldn't see this public address. The public address is actually a static one-to-one NAT that sits at the IGW. Now, from there, we can communicate with things like S3 and DynamoDB, the internet, and those services and the public internet will see the instance A in this case, represented as the 54 public IP address range, or the elastic IP. Now from there, we could have an ad instance, for example, and we've got a private subnet, and that private subnet has a route to the elastic network interface of instance B in this case. And then the NAT instance has a public IP, another elastic IP. Or you could use things like NAT gateway. So in this case, the private subnets will communicate with the outside world via this public IP that's associated with the NAT gateway. From there, we can actually add a whole bunch of different connectivity pieces to the VPC. So we've got an S3 endpoint, or a VPC endpoint for S3. We've got a VGW, or a virtual private gateway, and that's going to allow us to communicate on premises, either via a VPN or maybe even AWS Direct Connect. And you'll see we're building out the route table as we go here. You can also use VPC peering, and VPC peering will allow you to connect to other VPCs. But the public IP address here is really the elastic IP, and that's where that sits at the IGW. Most of the other pieces here you're seeing are all routed via private IP addresses and not public IPs. What we're actually interested in here for this presentation for Bring Your Own IP is the elastic IP. So the elastic IP, it's really the public IP that's associated with the VPC and associated with an instance. And what we'd like to do is bring our own. So it's this IP address that you see here that's highlighted in red. So your IP address it's not really just a number. So your IP address is really representative of you or your instance out in the public realm. Now, if you change that IP, it could mean that you lose connectivity. Now, that's where things like DNS come into play. But in some cases, you might want to keep that public IP the same. So we decided to build Bring Your Own IP. And what that looks like is you as a customer can bring your own subnet or CEDAR address range into AWS, something that you've owned previously and might be using on premises. And we've actually got Anupam here, one of the senior product managers for Bring Your Own IP. Anupam, do you want to talk about some of the reasons why we decided to build this feature?
Thanks, Matt. Why did we build Bring Your Own IP? So for most customers, the IPs we provide just work fine. They don't care about any specific IPs. But there are some who do care. One such use case is of customers who send commercial emails. Now for them, the reputation of their IPs is very important. They have built their email sending platform over the IP reputation. They have over years owned the reputation of these IPs, and because of that, they get high sending rates. Now, changing the IPs when moving to AWS is not desirable for them. So with Bring Your Own IP, they can move to their applications to AWS and still use their own IPs. This is great for them. The second and probably the most prevalent use case is of whitelisting. Often customers whitelist their IPs with their partners to maintain a security posture. Now, there could be customers who have whitelisted their IPs with hundreds of partners, and changing these IP addresses in the firewalls of their partners could be a big ordeal. Like each such change could take months, several security reviews, legal and compliance reviews, and even if the customer is able to do so, it's very difficult to time it across all hundreds of partners. So with Bring Your Own IP, customers who have whitelisted IPs can move their applications with ease and not worry about re-establishing the security posture with their partners. And the third use case is of migrations. Legacy applications often have hard-coded IP dependencies. There are applications who have taken hard-coded dependency on the IP addresses. Now, moving such applications to AWS means that the network administrators have to really make sure that all such dependencies are resolved. Now, let's take an example where there's a game server that has several client applications with the customers. Now, imagine the game server changing its IP, and each of these client applications have to change the IP because somehow the application had hard-coded IPs, or a server, sending messages to tractors and submarines out in the field. Now, if every submarine and tractor has to change their IP address, that's going to be a really hard thing to do. So with Bring Your Own IP, such legacy applications can be moved to the cloud with ease without worrying about whether it's going to break your applications. And the fourth has to be redundancy. There are customers who want to have AWS as a hot standby. They want to bring their IPs, set up their resources on AWS, and then keep this as a hot standby so that if there's a need, they can move the advertisement from their on-prem to AWS. Because in this feature, we also allow you to control the advertisement of the prefixes. I'm sure Matt is going to talk about that later in the presentation. Now, that's great. Like why Bring Your Own IP is needed. Now, the question is, how do you use it? How do you get started? So to start, the first thing you need is an IP prefix. You need at least a /24. That's the most specific prefix you can bring via Bring Your Own IP. You can bring a /22, a /23, or a less specific one. And then these IP prefixes need to be registered to you with respective RIRs. Right now we support Erin and RIPE. Now you have the prefix. That's great. Now, how do we make sure that we have the right authorization from you to use this prefix? So how do we know that you have authorized us to advertise this prefix? How do we prepare a prefix so they can bring it onto AWS? So with Bring Your Own IP, your security is our top priority. We want to make sure we have the right authorization from you to use your IP prefixes. Now, to seek authorization from you, what we ask you is to create a ROA. So you create a ROA to authorize Amazon ASNs 16519 and 14618 to advertise your address range. Now, what's a ROA? So ROA essentially stands for Route Origin Authorization. This is how Erin describes it. But essentially, a ROA is a way for you to saying, I'm allowing AWS to advertise these prefixes, and you are declaring that publicly. Only you and you can create a ROA for your prefix after you have authenticated yourself with Erin. Where do you get a ROA? You can go to Erin website, follow simple instructions, or you can go to RIPE website and follow simple instructions there. The links are present here, and that's how you create a ROA. The ROA is created. That's great. Now, what ROA tells us is that you have allowed us to advertise your prefix. But what it does not tell us is that which account do you want this prefix to come in. We want to make sure that the prefix you bring in comes to the right account. It comes to the account you intended it to come to. And nobody else, but only you can bring IPs to your account. So for that, we ask you to create first a RSA 2048-bit key pair. This is how you create it. You call the OpenSSL gen RSA command, and this saves the key pair in the private key file. The next step in the authentication process is to create a public X509 certificate from the key pair using the following command. Following step is to create a signed message. The format of the message is as follows. First part of the message is the version. It should always be 1. The second is AWS partition. Third is your 12-digit account number, which only you know. The fourth is the CIDR or the IP prefix you're bringing to AWS. Then its expiration date. The signature will not be valid after this date. Hashing algorithm and RSA PSS. Once you have the message created, we ask you to sign that message using the key pair you created. This is how you sign the message. And the fifth step in this process is to update the RDEP record of your RIR with the X509 certificate. You can run the cat command to view your certificate. And then for Erin, you need to go to the public comment section of your address range and update the certificate there. For RIPE, you need to go to the description field for your address range and update the certificate there. With these steps, your IPs are now ready for provisioning. I'm going to request Matt to join me and talk about how to provision these IPs on AWS now.
All right, thanks Anupam. Awesome stuff. So let's dive into the console here. We've got a bit of a mock-up of the console to talk about how we would do the provisioning of your IP range, and this really is where the rubber hits the road. We've done the authentication and the authorization steps, and again, security is of utmost importance here. We want to make sure that we are allowed to advertise your IP ranges, but now we're going to step into provisioning. Okay, so provisioning a range, you would start with the, in this case, the CLI command provision BYOP CIDR. And if we just open up a console here, And we'd run this by doing the AWS EC2 provision BYOP CIDR. We're specifying the region, the CIDR range. In this case, we're specifying a 130, 137, 24/23. We're giving it a description, and then you'll notice we've got the authorization message here as well. So this is the message that Anupam referenced earlier, and in that is going to be your signature as well. So the response from that, once you've run that command successfully, would be a format or an output here that would show that the CIDR 130, 137, 24, the description, and in this case right now, it's pending provision. So that's the state of the prefix when you first run this command. Now, if we did do, here we'll just clear the console again. If we did do a describe BYOP CIDRs, so in this case we want to monitor the status of our CIDR address range, we'd run the describe BYOP CIDRs, we specify the region again, max results 10. Obviously we don't want to flood the screen here with too many results if you did have a lot of CIDR ranges, and you'll notice the describe command in this case again has pending provision. So sometime later, if we do the describe command again, you'll notice that the CIDR address range will turn from pending to CIDR successfully provisioned into an IPv4 pool. And this IPv4 pool ID is going to be what you use to reference the pool of addresses that we've then taken that CIDR address range or prefix and placed that in. So you would then allocate addresses out of that pool. And I'll show you how to do that here. So in this case, provisioning has been completed. Awesome. Alrighty, so the next step that we want to take here from provisioning your IP addresses or your prefix into the pool of addresses is advertisement of the address by Amazon. So what this is going to do is take your address range, your prefix, and advertise it to the public internet. So folks out on the public internet know that to reach this prefix, they'll follow the path down into Amazon and into the Amazon region in question. So to do this, we just want to run an AWS EC2 advertise BYOP CIDR. We specify the region again, and then we specify the CIDR address range. In this case, it's the same /23 as we used earlier. Now the response here is going to now show that the address or the prefix or the CIDR address range has now or is now being advertised by Amazon. So your state there is going to turn to advertised. So next, we've got our address pool. We're advertising that prefix out to the internet. The next step is to create some elastic IPs. Remember, this is where we really specify public IP addresses. And in the VPC architecture we saw earlier, the elastic IP was what was representing EC2 instances, in that case, to the public internet. So what we'd like to do now is create elastic IPs from the IPv4 pool that we created earlier. So to do that, first we're just going to do a describe. And now we can see we're describing our public IPv4 pools, and we can see here that we've got a pool of the ID that we had earlier, we've got our description, and we've got, in this case, 512 addresses that we can allocate into elastic IPs. So that's actually pretty cool. Now the total address count and total available addresses are both 512 in this case. So next, let's allocate an address. And first, we're going to allocate an address at random. So if you don't mind what IP address you use out of that IP pool, you can just run this command, the allocate address, specify the region, the domain, VPC, specify the public IP pool, and that's it. And what will happen then is the response will be, we've allocated an address that we have chosen at random out of that IP pool. So now in this case, we've got a 130, 137, 24.135. So that's going to be our elastic IP we can now associate with an instance if we wanted to in this case. So what happens if you wanted to allocate a specific address out of that range? You wanted to choose what address to use. Well, it's pretty straightforward. We would just use the -- address prefix here in the command. So we're now asking to allocate a 130, 137, 24.77. And you'll notice here we've now allocated that specific address into an elastic IP, and we've actually got an allocation ID that's returned there. Now, if we wanted to allocate an address that wasn't in the IP pool or the bring your own IP pool that we've created earlier, you can just use the standard allocate address, the region, the domain, and we will respond with, in this case, we've chosen a 5241.102.233, which is out of Amazon's range. So we've actually just, in this case, allocated a standard Amazon Elastic IP. So now, if we wanted to describe the Elastic IPs that we have, we're doing the describe addresses command for region US West 2, and you'll see here we've got the first address that we allocated earlier, so that's the random address that we allocated. We've got the second address from the BYO pool, again that's the specific address. And then lastly we've got the Amazon address that we allocated earlier. So you'll see there's 3 Elastic IPs that we've actually allocated now. If we did do a describe public IPv4 pools, we'd actually see that we've got the pool ID from earlier, the description, and you'll notice the address count is 512, but available address count is now 510. So we've actually allocated 3 Elastic IPs, but we've only used 2 out of the IPv4 pool. So again, total addresses is 512 and the total available address count is 510. So we've allocated 2 of our 512 available addresses out of that IP pool. So you can have a combination of Amazon allocated, specific out of an IP pool, and random out of an IP pool, like we have here. So what happens if you want to withdraw the advertisement of the address by Amazon? So you're advertising, or Amazon is advertising the address to the public internet. You can also run the command withdraw BYOP-CEDAR, specify the region, specify the CIDR address range, and now you'll notice instead of being in a state of advertised as it was before, it now goes back into a state of provisioned. So what that's going to mean is Amazon is going to stop advertising that address publicly. So we're going to withdraw that prefix from our public IP or prefix CEDAR address advertisements. Now you can also deprovision an address range. So if you wanted to take that address range back and use it for yourself, after you deallocate all of the Elastic IPs from the pool, we just run the deprovision BYOP CIDR command, specify the region, CIDR address range, in this case again our 130.137/23, and you'll notice here the state of the CIDR has turned to pending deprovisioned or pending deprovision. Okay, so pretty straightforward using the CLI or API calls to specify Elastic IPs out of a pool, to advertise prefixes to the internet that you've brought to Amazon. Pretty awesome stuff. Let's check out the console now and see what that looks like. So we can allocate a new address from the console, just like we would with a normal standard Amazon Elastic IP. But in this case, and I'll zoom in a little bit for those of you who are visually challenged like myself, you'll notice that we actually have an option here to select the pool of IP addresses. So in this case, we're using our IPv4 pool that we allocated earlier. So you can do this stuff from the console as well. So instead of using an address provided by AWS, we're using an address from a custom pool that you've brought to AWS. If we have a look at the Elastic IPs through the console, you'll see here that we've actually got the 130, 137, 24, 135, and also the 77. So our 2 addresses that we allocated earlier, the specific IP, the .77, and the random IP, the .135. And we've also got that sitting next to the 52 address, the .233, which is the Amazon Elastic IP. So these Elastic IPs would sit side by side here in the Elastic IPs, and you can see them listed out here in the console. Okay, so pretty straightforward from a provisioning and advertising perspective. But I think there's probably a couple more questions that I have. And Anupam, if you're there, I'd love you to answer these. First question that comes to mind when I'm thinking about this sort of thing is, what's the most specific prefix I can bring via bring your own IP? Anupam?
Yeah, the most specific prefix you can bring is a /24. You can, of course, bring a /22, /23, which are less specific. So while we're talking about this, there's one question that has come often from customers, which I want to discuss as well. Is like, I have customers saying, hey, I have a /22, but I only want to bring the /24 out of it. Do I need to break up my prefixes into /24? And the answer is no, you don't need to. Even if you have a /22 and you want to bring a /24, you can create a ROA for the /24 itself. You don't need to create, 4 /24s individually in ARIN. So yeah, so /24 is what you can bring minimum.
Okay, and that's pretty awesome. So if I have a /22, I can just create the role for the /24 and bring that across. Okay, very cool.
Yeah, that's right.
All right, the next question is, can I move a CEDAR between regions?
Yes, you can move a CEDAR between regions. It's basically, you will have to deprovision the CEDAR from the region it's currently in, and then reprovision it to the new region. So it's pretty straightforward, all self-service with the APIs.
Okay, so if I think about an IP pool, it's really a region level construct. Then I'm bringing a IP prefix, and it will exist in that particular region. Does that sound fair?
That's right. That's right. So yeah, the IP pools are tied to a region and an account. So if you want to move them up, because EC2 is a regional service. So if you want to move those IPs from one region to the other, you need to first, not in order, but stop advertising those IPs, deallocate all the elastic IPs, and then when that is done, you deprovision the IPs, and that's when you take the pool out of your account, and then you have to reprovision the IPs. Now, you may not require to do all of the preparation steps, creation of ROA, depending on whether you're changing certificates or not. So if you don't change certificates, you're using the same ROAs, then you don't have to do the preparation part again. You can just start with the provisioning part.
Okay, awesome. Excellent to know. Thank you. Now, the last question I have is, will the CEDARs that I've onboarded in preview, I know we had a public preview for Bring Your Own IP. When we go public or GA, will those CEDARs be available?
Yeah, those CEDARs will just continue to work with no interruption. They would work like any other CEDAR that was brought through the public features. So there will be no difference between a CEDAR brought via the preview process or via the public feature once the feature is public.
Okay, awesome. Sounds great. Okay, so my CEDARs that I brought through the preview will work exactly like the CEDARs that we've onboarded after the feature's public. Very cool.
Yeah, customers would not even know about it. It will just work right the moment we move to public.
That's the way we like it to work. All right, that was all the questions I had that came to mind. Thanks very much, Anupam. I think this is an awesome feature, and I know I've got a lot of customers that are very excited about this one. So thank you.
Yeah, we have been very excited working on this feature. And I know, Matt, you are one of the advocates for this. Like, when your customers were always giving you feedback that we need this feature, and we were listening the same from our customers we were talking to. So I'm really happy that we have been able to get this done for our customers.
All right. And I think that's it, guys. I think that's all right.